Hello everyone, let's start with the series Roadmap to Become Competitive Programmer 5 star. So in this video, I'll be solving the 23rd problem and it is reverse the number. So given an integer and write a program to reverse it. Got it? So the first line contains an integer t, which is total number of test cases. Then follow. So basically first line they have given integer t. So let's take int t, say int t while t minus minus. Okay, so this will take care of all the test cases of. Then follow t lines. Each line contains an integer n. So in each test case there is an integer n. This will have to reverse it. So let's understand with the example. So they have given 4 test cases, and in first test case the number is 1 2 3 4 5. So let me take you to the blackboard. So in the first example, and they have given is 1 2 3 4 5. So we'll have to write an algorithm so that this n becomes 5 4 3 2 1. If you see 5 comes here, 4 next. So basically in this way we are writing the number. Okay, 3 2 1 5 4 3 2 1. So how do we solve this? If you clearly see, somehow this n is equals to 1 2 3 4 5. We have one more reverse n will take one variable which will be initialized to, let's say, 0. Somehow we'll have to take out this one, the number, the digit which is at the end. So we'll have to put here. Okay, so this is basically the first step. So in the next step, since our n is 1 2 3 4 and reverse number is 5, so we'll have to take one more this 5 and we'll have to put it here. So in the same way we'll remove 3 here, we'll put it in the reverse end. So we'll basically append it. So we'll remove this, we'll put it here, we'll remove this and we'll put it here. This will eventually go to 0. So this is the process that we'll need to follow. So how do we solve this again? So how do we get the last digit? Okay, n is 1 2 3 4 5 we have. So how do we get this last digit? In mathematics we have this modulo operator, right? If you do n modulo 10, that will give you the last digit. So let's take last digit. Okay, last digit is equal to n modulo 10. So 1 2 3 4 5 we have. If you do modulo 10, this will give answer as 5. Basically it will divide 1 2 3 4 5 with 10. So why 10? Because it is in the decimal number system. So this will divide and remainder will be 4. So remainder will be 4 and we have got this 5. Somehow we'll have to put this 5 in this reverse n. We have reverse n as 0. Okay, now let's say how do we put this 5? Let me put it this way: Rn plus equals to this last digit. So Rn plus equals to last digit means it will be 0 plus 5, with right now it is 0, and we have got last digit as 5, so it will be 5. So if you see, and n will have to divide it by 10. N is equal to n divided by 10. If you do this way, n, so n is 1 2 3 4 5. If you divide it by 10, this will give you 1 2 3 4 will give you. Okay, because 5 is the remainder, that will go away. Integer division, in integer division we will not be having reminder. So I think if you see, pretty much first step you have got it. In the first step like we will have to remove the last digit, put it here. So kind of looking the same way, n is 1 2 3 4 and Rn is 5. Now let's try to get the second step. Okay, so if you see right now we have n as 1 2 3 4 and reverse n as 5 we have. So again, how do we get this last number? So you'll have to do last digit is equal to n modulo 10. This will give you 4 basically. Okay, the remainder it will give you. So now we'll have to somehow put in this. So if you do Rn plus equals to last digit, so in that case Rn is 5, and if you're adding with 4, so that will give Rn is equal to 9, which is not we required. We require Rn is equals to 5 and then 4. So if you clearly see 5 was in ones place, somehow it will come in tens place. So if you try to multiply Rn by 10, okay, Rn is equal to Rn into 10. So this will give you Rn equals to 5 into 10, which is 50. Okay, somehow like in the second tens digit we have 5, but here we have in ones place we have 0. It should be like we'll have to get 4 here. So right now if you do Rn plus equals to last digit, then it will be fine. So you will get Rn is equal to 50 plus last digit is 4, which is 54. Okay, now in second step we have got Rn is equal to 54, but n value is still 1 2 3 4, so we'll have to remove this 4. For that you need to do n is equals to n divided by 10. This will give you 1 2 3 4 divided by 10, which is 1 2 3. So if you see in the second step, n was actually 1 2 3 4, but it has, and Rn was 5, so it has gone up 4 from here, it has gone to here. So if you see 1 2 3, here we have 5 4, so kind of it is reversing. So let me try to write third step, and I'll tell you the formula what we are using, so you will get the answer. So n is 1 2 3 4 4, and our answer has to be 5 4 3 2 1. Right now our n is 1 2 3, and reverse of n is 5 4. Kind of you're getting. Okay, so again now if you want to get last digit, what you will have to do? For last digit you will do 1 2 3 modulo 10. Basically n modulo 10 you will do. So this will give you 3. And now Rn you will have to multiply it by 10. Rn equals to Rn multiplied by 10, so that it will be 54 into 10, which is 540. So if you see tens and 100 plus are okay, but this one will have to take care. So for that you will have to do Rn plus equals to last digit. So this will give you Rn right now is 540. 540 plus last digit, which is 3, this will give you 543. Rn equals to 543. So kind of it is reversing. Now we have in n as 1 2 3, but you'll have to take n is equal to n divided by 10. So this will give you 1 2 3 divided by 10, which is basically 1 2. So kind of you're saying one digit we are taking from n and putting to Rn. So it is reversing. So in the fourth step it will be, in the fourth step we have n is equal to 1 2, and Rn we have 543. So now we'll have to get last digit. Last digit is equals to 12 modulo 10, which is basically n modulo 10. So 12 modulo 10 means 1, you'll get remainder as 2. This is last digit. Now Rn you will have to do Rn is equal to Rn star 10. So this will give Rn is equal to 543 into 10, which is 5430, and you'll have to do Rn plus equals to last digit. Now Rn is basically 5430 plus last digit means 5432. 5432. Got it? And n you'll have to do n is equal to n divided by 10, which is right now we have n is 12 divided by 10. If you do, that will give you 1. And remainder, I mean like 12 divided by 10, how it will happen in integer division? 10 divides 12 by 1 time, and like 2 will be remainder. So 2 divided by 10 means it will be 0 in integer. But if you take double or float, they'll give you 1.2 as value. Okay, but here we will be using integer, so that it will reverse will happen. So if you see here in the fifth step, n is 1 and Rn is 5432. Now this is the last step. Whenever this n is greater than 0, till that time we'll run a loop. So now last digit if you want to get, that will be n modulo 10, which is 1 modulo 10, which is 1 last digit. Rn will have to do Rn star 10. Rn is equal to 5432 we have into 10. This will give you 54320. Now Rn is equal to Rn plus last digit. So Rn equals to, Rn is now here 54320 plus last digit is 1. So this will give you 54321. So as you can see, we have got reverse number s of 1 2 3 4 5. We have got 5 4 3 2 1, and here n will be n divided by 10. N is 1 divided by 10. That will give you answer 0. So we'll be running through a loop. Whenever n is 0, in that time we'll have to stop it. I think pretty much we got how we'll be solving this. Let's try to code it up. So int n is given. We'll have to take reverse n, which will be initialized to 0. We'll run a loop, let's say while loop, that will be running when till n is greater than 0. Okay, once n is 0, we'll stop. So that time we'll be getting the reverse of number n in Rn. So now one thing we'll have to take last digit, which will be n modulo 10. Once we got last digit, we will we will decrease the n basically. N is equals to n divided by 10. So from n the last digit is gone. Now this last digit we'll have to append to that Rn. So we'll take Rn star, Rn is equal to Rn star 10. So we have basically used this formula to increase Rn by one position to the right side in the decimal number system. Now Rn is equal to Rn plus last digit, and at the end, once n is 0, so we'll come out of the loop and we'll have to print this Rn. Let's try to run the code. So our output is 0. Why our output is 0? We'll have to figure out here. Rn is equal to star equals to 10 we have got. Now Rn is equal to Rn plus last digit, which is correct. Okay. N is equal to n divided by 10. We are printing Rn only. Why it is 0? Sample input all are 0. 1 second. I think the reason why we are getting 0 is that, see, n we have initialized, but we are not taking input as n. Okay, I think when we are not taking n as input, so that time n is treated as 0 only by default, and it is coming out of the loop. And Rn, since we have initialized to 0, it is not entering anything here, so it is returning as 0. Now let's try to run the code. Now we got 54321 30213 321232. So let's try to submit the code. Yeah, it got accepted. So that's it. It was an easy problem only. So basically you'll have to use some of the mathematics formula to get the remainder, and how to increase the Rn by one digit placed to the right side, and then adding the last digit. So I think from the first example you got clear. So if you try to do whatever I did, if you try to do same with the second, third, and fourth examples you will clearly see how this works, and basically that will be a dry run that you will be doing. So yeah, that's it guys from my side, and thank you for watching the video.